Hello, Atmospheric Science students. Dr. Shragi here, and I want to talk to you today about one of the most difficult concepts in C, but unfortunately also one of the most useful. Maybe it's the other way around. Unfortunately difficult, but definitely useful, whatever the way you want to say about it, and that is functions. Functions are an incredibly important concept in how you write any programming language. And to get an idea of what we mean by functions, I want to tell you, to think back to your experiences of functions in a math course. I mean, you've seen functions all the time in a math class. They could be explicitly a function like x is the sine of y. Well, sine is a function, okay? Something happens to the number y, and you get a new result that replaces sine of y with some number that then goes into x. Or you could have a function like x equals 3y squared. Y is sort of the input to the function, then we square it and take it times 3, and that number then is the right-hand side of this equation to become x on the left-hand side. Functions, therefore, are operations. Something is happening, and they have both an input and an output when they run. The input to the function, these PowerPoint arrows aren't drawn very well. The input would be like the y in this case. In the world of computers, we don't usually call that the input to the function. We usually call that like the argument to the function. So like this is a single argument. It's a number. Y is a variable. It's got a number in it. And when we put that number in there, it goes off to the function sine. Someplace on the computer, there's a function called sine. Somebody wrote that program in something like C, maybe not C, I don't know. And it takes that number that came to it, in this case the value of whatever's in y, and based on that number, a whole bunch of amazing math happens, and the result is the sine of y, which then comes back from whatever that mysterious function is someplace on the computer, and now is equal to that right-hand side, that sine y gets replaced by that number, which then x is equal to. Okay, the output, I'm not sure I would necessarily have labeled, again, I'm not sure I'm so much in love with the way I made this PowerPoint, I'm not sure I'd say that x is the output here. X is set to the output of this function. The right terminology is that this function sine returns a value. A value comes back and replaces sine of y with the number between -1 and 1 that is the sine of y. Now, lots of functions in C are built in. Well, that's kind of a lie. I mean, something like sine, it's not actually built in. It's actually part of math.h, which you are always using the #include command to make part of your program as well. But you can think of them as, for all intents and purposes, built into C. In fact, they're not. They are external to C, but you include the math libraries, and then they're part of C. So this is a built-in function in C. You can think of it that way. There are other built-in functions that aren't necessarily quite so mathematical. For example, printf is a function. It has input or an argument. In this case, it's that string of characters HELLO!!n, which printf takes as input and does something with. Now, it is not like x is equal to printf. Okay, in this case, there's no output except like to the screen. The printf function does something with that data that came to it, that input, that argument that came to it, but it doesn't actually, return a value, which then goes into like x is equal to printf or something like that. Now, what's useful about these functions is that you can write your own. Okay, if you knew a better way to compute sine than what the person who wrote math.h knew, then you could write a new version of sine, and it would work better than the version that's in, maybe it's accurate to more digits or it's faster or something like that. Now, you're not likely to do that because the built-in functions in C's math library are very, very good. But you could reuse them. Or you can make your own functions that do something you need. And of course, in an atmospheric science class, a good example of the kind of functions that we're going to be working with are functions that know how to convert units. Like, for example, we're going to work on an example here that converts Fahrenheit to Celsius. Now, this is an actual function that you're going to need in your program that you're working with in this class. But we're going to write a function which we're going to call f to c. Okay, actually, I could care less what you call it. You want to call it f and the number 2c. If you want to call it Fahrenheit to Celsius, feel free to type Fahrenheit and Celsius all those times. I don't care. But we're going to make a function, because isn't something like f to c a useful function? I mean, if we get numbers in Fahrenheit, from surface observations. Well, nothing in meteorology really uses Fahrenheit calculations. We have to have a convenient way to change those numbers from a Fahrenheit, like a temp F, into a Celsius temperature with a number named like temp C, right? So you can see how this function that we have here is just so handy. I mean, if we actually had a function called F to C, where we could just send it, hey, I've got a temperature in Fahrenheit that I just prompted the user for, or read an observation from a file, or however we're going to get it, and it's in Fahrenheit, I just want to do that math of converting it to C. Now, we wouldn't need this function. You could sit there and say, it's parentheses temp F minus 32 times 5/9 every time. But that's just error prone, right? Sooner or later you'll make a mistake doing that. Rather, get a new function called F to C to work, and then just use it forever, okay? You'll always have this in your toolkit, in your set of meteorological calculation tools. You'll have a function, F to C, or Fahrenheit to Celsius, or whatever you want to call it, that is a tool. It converts Fahrenheit observations into Celsius, and boy, you're going to probably want one that's C to F for Celsius to Fahrenheit. You'll probably want one that's C to K for Celsius to Kelvin. And there'll be lots of these, meters per second to knots and so on. But we'll have other uses for functions too, like how to compute things like potential temperature and so on. Let's see how they work. Now, I'm going to tell you right here and now that this little sample piece of program that I have here has a function in it. Well, technically it has two functions, the main function and the new F to C function that is above it in the code. Functions are generally above main. That doesn't necessarily mean they happen first. Remember, execution of the program is going to be starting at main, but the compiler wants to see these functions first so it knows what they are. When it gets into your program and it sees F to C, it wants to know what that is. Well, you'll have defined it up higher in your program, but you'll see how it is. So typically, one way to make your functions is to put them between the pound includes and the main part of your program. Now, I say that with sort of air quotes here because we're actually going to put our function someplace else most of the time, but that would also work. So let's do a little autopsy here on this program here, dissect it a little bit and see what happens. We have this F to C function up here. It's a little piece of code, and functions get declared, just like any variable would be. They are declared in the sense that we have to tell the compiler what kind of number is going to come back. Someplace buried in the math.h libraries, there is a function called sign, and we give it a number called, let's say, y, and it's going to return the sign of y. The sign of y is a floating point number. So someplace in math.h, or the libraries it links to and so on, there is something that declares float sign, where it is saying the value that is coming back from this function, that is returning from this function, is going to be a floating point number. It could have been an integer or whatever. You'll see that there's other examples as well. And then you give it its name, F to C in this case, and then in parentheses, you need to tell it what kind of information is going to come into this function, the arguments or parameters of this function. Well, in this case, it's going to be a floating point number. F to C expects a floating point number to come in. And in this program, inside of this function, we're going to call that floating point number TF. That doesn't mean it was called TF. We invoked the function way back in our main program. Any more than, for example, you don't know what goes on inside of the sign function buried someplace in math.h or the math libraries. Okay, you can send it sign of x or sign of y or sign of theta. That value of x or y or theta or whatever, the value in there goes off to the sign function, and inside of the sign function, I don't care what it's called. I mean, if they want to call it theta, they want to call it r, or they want to call it z, I don't care. And in the same way here, inside of this function, the user doesn't care what's going on inside this function, but you as the author of this program, you care. So here, inside of there, you're going to have called it TF. It's just going to be a floating point number that is going to be part of your function. And you need to make sure the computer understands that this value that's coming from that's being passed as an argument into your function is going to be a floating point number that in this case you're calling TF. And then inside the function, there's just code. It just works like it does in the main program. you're saying, hey, what are you going to do here? Oh, maybe I need another variable called tc. Tc is going to be equal to tf minus 32 times 5/9. Great. You could even call other functions inside of this function, like if you had other things going on in this program. We'll see some examples of that. Okay, but then when you're done, okay, in this case, this is a pretty simple function. All I need to do now is send the value tc back to the main program. So we say return tc. So the number that's inside of tc, not the variable tc, but the number inside of it is going to get sent back to the main program. So let's actually see what happens. We're going to start at the top of the main function. Oh yeah, main is actually, strictly speaking, a function here. And we're going to say, okay, we declared two variables, temp C and temp F. Temp F, we're going to say 98.6. Temp C, we'll say, is equal to F to C of temp F. So that value of temp F, 98.6, is going to go into, it's going to be passed to the F to C function. And inside of there, it'll be calculations will happen on that variable called tc, and then we'll return tc, whatever 98.6 Fahrenheit is in Celsius. F to C of temp C will then be replaced by that value. It'll have been returned. Temp C is equal to that. When you're actually running this, keep in mind, I mean, C has no idea what F to C is, so it's just looking to see if it's a function, and it is. That value of temp F got passed to F to C, and inside it to F to C, that value got called TF. TF is just a local variable inside of this floating point function F to C, and inside of there, math can happen to it. But when we leave that function, all those variables, and go back to the main program, all those variables that were inside of F to C are destroyed. Okay? So TF and TC are gone. That memory is freed back up to be used for something else when we go back to the main function and return that value into F to C and then put it, in this case, into TC, which we could then use to print or something like that. And this is actually really brilliant because you can reuse these functions. I mean, there's some math going on someplace on your hard drive or on Chesapeake's hard drive that knows how to compute sine. Aren't you glad that that's just one place on your computer? How should I put it? Like in your program, if every time you wanted to compute the sine, you had to, put all that code in there as to how to compute a sine, it's a whole lot of math as to how that's done. On the other hand, just being able to use sine or cosine or tangent or whatever, and it just goes, the execution of the program leaves the main program and goes off to some math library and just uses the code somebody else wrote and tested and debugged and made sure it works. That's brilliant. It's just getting reused over and over again. It's perfect. The same function can be used over and over again. In this case here, notice I have in my program, we did the F to C function there twice. We invoked it twice. We got to reuse our code. It's perfect. There are some functions out there that don't return anything. That's called a void function. For example, we could make a function called print a value. Okay, where maybe we didn't like the printf function, but we could just say, in this case here, I'm making a little function called print a value, where I could put values into value 1 and value 2, and then I could print a value, value 1, and print a value, value 2. And when I invoke these functions, they go up into, execution is passed into the print a value function, where the value is printed in whatever, a pretty way or whatever. There's nothing that gets returned in this case because it isn't like x is equal to print a value. It's just a void function. The function does something without actually returning any values here. Nothing is equal to print a value. I'm going to stop here before I go into this part about multiple inputs because that gets a little bit more complicated. I want to make sure that we're clear about a few things first. I'm going to first stop this recording here and switch over to a window, and we're going to mess around and write a few functions of our own.